The ocean covers more than 70% of our planet, yet we've explored less than 5% of it. Below the calm blue surface lies a world of darkness, pressure, and mystery, so extreme it can crush metal and distort time itself. Today, we journey into the unknown. These are three of the most shocking deep-sea dives ever made, dives that tested the limits of technology, human endurance, and our understanding of the ocean itself. For centuries, humans feared the deep ocean. It was thought to be lifeless, a black void beyond reach. But with advances in submersible technology and underwater robotics, explorers began to see what truly lies beneath. In the 20th and 21st centuries, deep-sea diving evolved from risky curiosity to a precise science. Engineers designed titanium hulls that could withstand crushing pressure. Scientists developed robotic arms to collect samples miles below the surface. These dives didn't just reveal strange creatures. They helped us understand our planet's geology, the origins of life, and even where life might exist beyond Earth. Today, we journey into the unknown. These are three of the most shocking deep-sea dives ever made, dives that tested the limits of technology, human endurance, and our understanding of the ocean itself. Our first dive takes us to the very bottom of the world, the Challenger Deep. Located in the Mariana Trench, this point sinks nearly 11 kilometers, or about 36,000 feet beneath the ocean's surface. To put that in perspective, if Mount Everest were dropped into the trench, its peak would still be underwater by more than a mile. The first humans to reach this depth were United States Navy Lieutenant Don Walsh and Swiss oceanographer Jacques Piccard aboard the Trieste Bathyscaphe in 1960. Their steel sphere, barely large enough for two people, descended for nearly 5 hours before landing in the silent mud of the ocean floor. Through their tiny window, they saw something unexpected. Small shrimp-like creatures moving across the sediment. Life, even at those impossible pressures. More than 50 years later, in 2012, filmmaker and explorer James Cameron repeated the dive solo in his custom-built submersible Deep-Sea Challenger. Cameron's dive reached 10,908 meters, capturing high-definition footage and collecting geological samples never seen before. Since then, other expeditions, including the Five Deeps expedition in 2019, have mapped the area in greater detail. Each mission confirmed one thing. Even in the deepest, darkest corners of the planet, life adapts and survives. Our second dive takes us not to the ocean, but inland, to the heart of Siberia. Lake Baikal holds about 20% of the world's unfrozen fresh water. It's also the deepest lake on Earth, plunging to 1,642 meters, or roughly 5,387 feet, beneath the ocean's surface. In 2008, a team of Russian scientists launched a series of historic dives using two small submersibles, Mir-1 and Mir-2. Their goal, to explore the geology and biology of the lake's mysterious depths. During one dive, the submersible descended through layers of freezing water and organic sediment. At the bottom, cameras captured methane seeps, streams of bubbles rising from the sediment. These gas seeps help scientists understand how greenhouse gases are released from the Earth's crust and how they may influence climate systems. What truly shocked researchers, however, was the discovery of unique microbial life thriving in near-freezing temperatures and high-pressure environments.
Some of these microbes feed on methane, helping regulate the lake's chemistry and offering clues about life on icy moons like Europa and Enceladus. The Lake Baikal dives didn't make global headlines like the Mariana Trench missions, but scientifically, they were just as groundbreaking. They revealed that extreme ecosystems aren't just found in the oceans. They can exist even beneath the ice of a frozen lake. Our final dive takes us to one of the most alien places on Earth, hydrothermal vent fields deep along the ocean floor. Hydrothermal vents, sometimes called black smokers, are fissures in the Earth's crust where seawater meets magma. Superheated water, reaching temperatures of up to 400 degrees Celsius, bursts out, carrying dissolved minerals and chemicals. When this water hits the cold ocean, it creates towering plumes of black smoke. In 1977, researchers aboard the United States research vessel NOR made the first human-observed dive to one of these vent sites near the Galapagos Rift. Using the submersible Alvin, they expected only barren rock. Instead, they found an entire ecosystem. Giant tube worms, clams, crabs, and bacteria, all thriving without sunlight. These creatures relied not on photosynthesis, but chemosynthesis,